Branches are one of Git's most important concepts. In this course, Tobias will give you a thorough understanding on how branches work in Git. And don't forget to hit that subscribe button so you don't miss any of our great courses.
Hello, Free Code Camp friends. My name's Tobias, and I'm going to explain how to work with branches in Git. One of the core and most important topics in Git and version control is how you can productively work with your branches and what you can do to start off. But before we go, let me have a huge shout out to the people at freeCodeCamp for teaching people how to code for free on the internet. Thank you so much for being on that mission, and thank you for letting me help a little bit with that contribution. A couple of words about my background. I'm part of the team behind Tower. Tower is a graphical user interface for Git on Mac and Windows. And we've been around for more than 10 years now, and in those 10 years, we've helped around 100,000 people in companies big and small, freelancers, every developer in every part of the world, work more easily with the Git version control system, take the headache out of Git and make it more easy. This workshop today will not be about Tower. Don't worry, you don't have to have Tower installed. We will do everything on the command line so you can follow along no matter what you're using. So before we start, what's this going to be about? Branches are one of the core concepts in Git, and there's really an endless amount of things you can do with them. You can create and delete them, you can compare, you can merge and rebase them, you can publish and track them. So we're talking about all of those things that you can do with your branches. Before we dive into the specifics, let me just briefly talk about two core concepts that I'll mention again and again. So one is the head branch. If you don't know that term, that's pretty important. It is the currently active or the checked out branch. You can have many branches in your repository, but you can have only one that is active at a single time. So if you hit git status on your command line or are in a graphical user interface, you will see you are on a certain branch. In this example here, on branch master. So master is currently the head branch, the active branch. And the other core concept is the distinction between local and remote branches. So when we're working with branches, we are in 99% of the time, or 95% of the time, we're working with branches in our local Git repository, right? The remote branches in your GitHub, GitLab, Bitbucket, Azure DevOps, whatever you have, they're more for synchronizing, right? The bulk of the actual work happens in your local branches, on your local machine, in your local Git repository. All right, let's start by creating new branches. Right, so before you can work with branches, you of course need to have some in your repository. And to create a new branch, you can just use the git branch command and provide the name of your branch. So my new branch is the name of that new branch. And when I do it like that, when providing just a name to the git branch command, Git will assume that I want to start my new branch based on the currently checked out revision. So I'm going to create a new branch on the situation that I was to this point. So if I'd like to create a new branch at a specific other revision, let's see what revisions we have in this repository. By the way, so this is Tower, the graphical user interface that we make. So here is my new branch. I just created that, so that worked. Good news. If I want to create my branch on a different revision, let's say I want to start, here. I can just copy the revision hash of that commit here. And then on the command line, I can type git branch other branch, that's the name, and I want it to start on that revision here. All right, let's see what that did. All right, a new branch, so that worked, and it started on that revision here, right? So you're pretty flexible with how you want to start your branches. And again, as I mentioned briefly in that core concept area just a few seconds ago, you can only create new branches in your local repository, right? Creating branches in a remote repository happens by publishing an existing local branch. So I can I can upload these here, but I can't create a branch on a remote. We'll talk about that later on. All right. Git branch, either without mentioning a specific revision, then it's going to be your current revision, or mentioning a specific one to start it on a specific revision. All right, switching branches. Of course, another very important action you're going to use all of the time. So the current branch, the checked out branch, so to say, or the head branch, it defines the context your work is in at the moment. And the current head branch is where new commits will be created. They will be created in that context. And to change the branch you're currently working in, this means to check out another branch or to switch a branch. And let's see how we can do that. All right, so at the moment, if I hit git status, I can see I am on branch main. So main is currently checked out. This is my head branch. And if I want this to be a different branch, I can type git checkout. And well, we have so many beautiful new branches. Git new branch. And voila, I've switched to branch, my new branch. So the git checkout command is pretty versatile. It's used for so many things. In recent years, there's been a new command added to the Git command palette, and I would suggest you use git switch in the future, because git switch is only for this purpose. It's only for switching branches. So if we want to switch to, well, we created other branch, I can type git switch other branch. And git switch, as I said, is a little bit more unambiguous because it only has this purpose. Git checkout is a command with lots and lots of meanings, so I'm more comfortable using git switch, git checkout, and git switch. Again, so you can see in a graphical user interface, this is where the head pointer now points to. So other branch is currently the checked out, the active branch. Okay, number 3, renaming branches. It's pretty easy to mistype a branch's name or to change your mind after the fact. So don't worry, you can rename branches, of course. And Git makes it pretty easy to rename your local head branch. So let's do that. So we are currently on, again, let's type git status to make sure we are on branch other branch. And if I'm not happy with that naming, I can just change it using git branch with the -m parameter and then provide a new name. So better branch, let's call it like that, and take another look. Okay, I'm now on branch better branch. That was pretty easy. So in case you want to rename a different branch, not the head branch, not the currently checked out branch, then we have to provide the name of the old branch to make this unambiguous. So at the moment we have, let's see what branches we have. We're using git branch without any parameters. All right, so better branch, main, and my new branch. So let's say I want to rename a non-head branch, a branch that is not currently checked out. Let's say I want to rename my new branch here. So let's make some room. All right, so let's rename git branch -m my new branch and call it my better branch. Let's see if that works. Git branch without any parameters shows you what branches you currently have, and voila, we just changed the name of a non-head branch like this. So these commands are used to work for changing local branch names. If you'd like to rename a remote branch, things are a little bit more complicated because Git doesn't allow you to rename remote branches, really. So in practice, renaming a remote branch can be done by deleting the old one and then pushing up, publishing the new one from your local repository. So let's take another look at what we have. So if I'm not happy with origin staging, that naming here, I can delete that and then re-upload it. And I'll show you how to upload your branch for the first time in a second, so we can see how that works. All right, renaming branches with the git branch -m command. And if you have a non-head branch that you want to rename, provide the old name and then the new name. This is for renaming remote branches, and we'll do that while we are creating a new branch and pushing that for the first time, so we can do two things in one. All right, publishing branches. As I already said, it's not really possible to create a new branch on a remote repository. What we can do, however, is we publish an existing local branch on a remote repository. So we can upload what we have locally to the remote server and thereby share it with our team, right? So let's see what we have and what we can publish. Okay, so at the moment we have this beautiful feature uploader branch here, and it's not present on the remote. So let's say I want to publish that for the first time. I want to upload it to the remote server named origin. And let's do that on the command line. So I can just use git push -u. I'll explain what the u flag is in a second. On the origin remote, and it's the feature uploader branch. All right, looking good. All right, here we go. So we've just uploaded that to that branch here, that local branch, to the remote repository. Now, we'll be talking about this -u flag here in great detail in a second, but to give you the nutshell right now, it tells Git to establish a tracking connection. And this means pushing and pulling later on will be much more easy in the future. So let's talk about that in detail, because the whole topic of tracking branches is really important to understand. So by default, local and remote branches have nothing to do with each other. They are stored and managed as independent objects in Git. But in real life, of course, local and remote branches often do have a relationship with each other. For example, a remote branch is often something like a counterpart of a local one, right? So such a relationship can be established in Git. So one branch, typically a remote one or a local one, can track another one, typically a remote one. So in this little diagram here, you can see we have a local branch that's called develop, and we have a remote branch on the origin remote that's also called develop. And of course, I want them to have a relationship with each other. They're the counterparts of each other. And with that tracking relationship established, when I later pull or push, when I push from my local branch or pull from my remote branch, I can simply use the vanilla Git commands. I can use git push and git pull without any further flags or parameters, because the tracking connection already knows and it can fill in the blanks. So which branch on which remote do I want to push to or pull from, for example. All of that is already saved in the tracking connection. And we've already used such one way to establish such a tracking connection when we used git push with the u option to publish that local branch. And after that, as I said, we can just use git push without mentioning the remote or the target branch or the source branch. This all works out then. And this also works the other way around. So what we did was publish a local branch to a remote repository, but we can also go ahead and track or download a remote branch and bring it to the local repository, right? The other way around is also possible, and we can also establish a tracking connection like that. So let's see what we have. This would be number 5. And we currently have, right, a feature login branch on the remote that is not present here in my local branches. So let's say somebody else worked on that feature login branch and I want to join that work, and work with that branch. So let's get that branch to my local branches. And the way to do that is either to use git branch with the --track option, and this will be feature login, and it's coming from origin feature login. So by that, I created a local branch called feature login that is based on origin feature login, and they know about each other, right? I established that tracking connection, and voila, here we go. We now have that locally, and in a graphical user interface like Tower, I can see that, yes, there is a tracking connection, right? This local branch tracks the remote one. Another way to do that, well, let's create another branch, feature downloader. So we have another local branch that is not present on the remote. I will publish that really quickly and then remove it from here, from my local branches. All right, so again, we have that situation. I want to have that feature downloader branch on my local branches. And currently it's only present on the remote. So another way to do that instead of git branch --track is to use the git checkout command. And again, with the track option, so that's the same. And I'm basing that on origin feature downloader. And by not naming a local branch, so I'm just specifying the base remote branch, Git uses that branch name for the local branch's name. So I now have feature downloader here again, same thing as before. So it doesn't really matter if you're using git branch --track or git checkout --track. It's just another way of doing that. Okay, tracking branches, very important, either with git branch --track or with git checkout --track. Pulling and pushing branches. So once you have your tracking connection set up properly, pulling and pushing is really simple and almost boring, actually. So that's why I strongly suggest to work with the commands I showed you before, either when publishing a local branch with git push -u, or when tracking a remote branch from the other side with the git checkout --track command. Because again, once this tracking connection is set up, all you need to do is use git pull and git push to sync your branches, right? Git pull to download new commits from the remote, probably from your colleagues, and git push for uploading or publishing your own new work to the remote server. You don't need, with these tracking connections set up, you don't need any additional parameters. You don't need to specify the remote, like origin and the base branch or the target branch or the source branch. Just git pull and git push is enough. So that's the real advantage of using those tracking connections. Let's take another look at what we have here and see what's happening. Okay, so currently we are on the feature login branch, and another advantage of having those tracking connections set up is that Git tells me if my local branch and the tracked remote branch diverge. And that means that, let's take another look at Tower and what this looks like. So this feature login branch here has little numbers here, and this means one commit hasn't been pushed yet. So the remote version of that branch doesn't have one commit that I produced locally, and the other way around, two commits are present on the remote end. So probably a coworker or a teammate made some commits, and I haven't pulled those down. I haven't downloaded those. So this is really interesting to stay on track and understand how local and remote branches diverge. If there's something that I forgot to push or haven't pushed yet, or if there's something that I need to pull, I need to update. And with on the command line with the git branch -v command, I can get the same information. So I see feature login is ahead 1, behind 2. Ahead means I have a local commit that is not pushed yet. Behind means I am behind the remote, so there are new commits on the remote that I haven't pulled. Pretty interesting information to understand where you are, how current your data is, you could say. All right. Deleting branches. So most branches are not meant to live forever, and I encourage you to do a little bit of house cleaning now and then. And here's how to delete a local branch. That's pretty easy. So let's move to number 7 and see what we have. Okay, feature uploader and main are there. The first thing to know is you cannot delete the current head branch. So if I were to type git branch -d and feature uploader, I would get an error message because as I said, I can't delete the branch that is currently active, that is currently head. So first I would have to step away from that, git switch main, make main or another branch active, and then I could use git branch -d and feature uploader to do that. Uploader and deleted branch feature uploader. So this is now gone, right? I deleted that. In some cases, you will again get an error message because let's say you have worked on a local feature branch for some time, produced some commits, and then understand, okay, this doesn't lead anywhere. I need to delete that. You've produced new commits that are present nowhere else. And if you try to delete that branch, Git will say, well, be careful. You are about to delete data that is present nowhere else. These commits haven't been integrated into other branches. So are you really sure? And that's when you need to use the -f option, to force the deletion. Needless to say, I guess that this is quite a destructive action with -f for force. So be careful you have a hard time getting those commits back. You can, don't worry, but it has its reasons why Git warns you, well, these commits are present nowhere else. Are you sure you want to delete that branch? Another thing you might want to do is delete a remote branch. And as you already know, working with branches on the local end is different than working on the remote. So it's a different command, git branch. Let's see what we have first. So let's say we want to delete that origin feature downloader branch here on the remote. And we can do that using git, clear up a little bit, git push again. And I want to remove something from origin. And the delete flag is used here for feature downloader. And let's see. All right. Boom, there it is, gone. So maybe another important thing to remember is when deleting a branch, doesn't matter if it's a remote one or a local one, keep in mind to check if you should delete its counterpart branch too, right? The tracking branch. So for example, if you've deleted a remote feature branch, it might make sense to also delete its local tracking branch. That way you make sure you aren't left with lots of obsolete branches and a messy Git repository, of course. So always keep in mind when I delete one branch, is there a counterpart branch on the other end, either local or remote? And should I delete that too, maybe? Okay. Deleting on the remote with git push and --delete. Merging branches. A pretty interesting topic. Merging is probably the most common way to integrate changes. So essentially you're bringing new commits from another branch into your current head branch. That's always the direction, right? You're integrating into your current local head branch from another branch. And merging in most cases is very easy in Git and very simple, different to other version control systems. So that's one reason why it's so popular. And essentially it just requires two steps. So first you need to make active the branch that you want to have the changes come into, that should receive the changes, and then execute the merge command with the name of the branch that has the desired changes. Let's see what we have here in our example scenario. Okay, so at the moment, main has a new commit that is this one here, title of error page corrected, and uploader has also a different commit, clarify CSS background rule. So they diverge, and let's say I want to integrate this commit here, or these changes, the new commits on feature uploader, into main, right? I want to bring the new changes into the main branch. Then I can just switch to main, make main active, and then just type git merge feature, what was it? Uploader. And voila, I'm getting an editor window. Why is that? Because merging, most often, not always, produces a merge commit, right? Think of that like a knot that combines or that connects two branches. And this is a new commit, so I can provide a new commit message. And I'm going with what Git provides here as a standard merge branch feature uploader. Just close that. And let's see what happened. On main, voila, I just combined these two branches, and I have all of the changes here from both branches. So this is what the end result looks like. As I said, there is this merge commit here that combines the changes from both branches. And there is another way of integrating changes, and that is rebasing. So this is just an alternative way to integrate commits from one branch into another. And it's very important to stress that this is not better or worse. This is not the pro version and the merge is the beginner version. It's simply different. If and when you're using rebase, it mainly comes down to your personal preferences and the conventions in your team and the situation. So some teams love rebase, some prefer merge, and some do in some cases and not in other cases. So it's not a matter of better or worse. That's important to understand. So let's compare merge and rebase so you understand what's the difference. So this is the starting situation. We have two branches. We have branch A and branch B, and both have diverting changes or different changes. So we have a couple commits here and one commit here, and they were branched off on this point here. Now with merge, you've already seen that we would receive this merge commit in the end, this melting point or this knot that combines these two commits. Using rebase, on the other hand, the end result will look quite different. So especially because there is no separate merge commit that will be created. This is a big difference. Using rebase, it appears as if development history had happened in a straight line. There's not this branching out anymore. It happens, or it looks like it was a straight line. And this has its pros and its cons. So, but that's the result and the big difference. And then starting the actual process is pretty simple, but let's do that in practice. This is case number 9. And let's see what we have. All right, so a pretty similar situation like before. On feature uploader, I have two commits, these here that are present nowhere else. And on main, I have this here that is present nowhere else. And let's say I would like to integrate the changes from main into my feature uploader branch, right? So the first step would be to switch to feature uploader to make that the head branch, because as with merge, I am always integrating into my head branch, right? The head branch is the one that's being manipulated. I am already on feature uploader, so nothing to do here. But the second step is git rebase, and I want to rebase on main. And that was already it. Let's see what happened. Now you can see this title of error page corrected commit that used to be on main is now also present here on uploader. And as you can see, there's not this branching out, this melting knot, no merge commit. This looks like a straight line, and that's the big difference between merge and rebase. Again, if you're using a graphical user interface like Tower, you can just drag and drop to merge, or if you keep the Alt key pressed, it becomes rebase. So these actions are pretty straightforward in a graphical user interface. All right, and so this is rebasing again. And final case or final action, comparing branches. Sometimes it's pretty helpful to compare two branches. So for example, before you decide to integrate or delete a branch, you want to see how it differs from another branch. Does it contain any new commits or not? Do I still need those? What's the difference? So let's do this in practice and see what we have. So similar situation to just before, feature uploader and main, they diverge, they have different commits, and let's compare that and see what is actually different between them. So I can type git log main feature uploader. And this shows me which commits are in our feature uploader branch, but not in our main branch. And thereby I can see, okay, these two commits are here, but not here. And this would also, of course, mean if I integrated into main, these two commits would make it into the integration. So I can understand the difference between those two. If I want to see what's the difference between a local and a remote branch, I can also do that. Same thing actually. So let's compare my local main with the origin main. And the process is pretty similar. Git log main. All right, let's start with origin main and main. And I can see, okay, I have one commit currently in my local main that is not present in my remote branch origin main. So I know, okay, if I pushed now, I would upload this commit here because it isn't present there. All right. I think this is it for today. To help you remember what you learned, I prepared a little cheat sheet about this topic, so about all of the different commands that you can use in regard to working with branches. Just hop on bit.ly, Git Branches cheat sheet, and download that for free. This comes in handy in your daily work, I'm sure of it, and you can download the cheat sheet for free as you like. I hope there's a little bit of new information for you here in this workshop and in the cheat sheet. Have fun creating, deleting, renaming, tracking, pushing, pulling, comparing branches, and work with Git. Thanks for your attention. Take care.